This is the DP400 from MSI. It's a top-of-the-line machine that doesn't have RGB, but does have a 5090, and does have an i9, and is the 2025 PC Magazine Reader's Choice machine. I recently got to hang out with some of those guys. That was fun. Anyway, this is supposed to be a no-nonsense machine. Let's see how it stacks up against machines that we build. Core Ultra 9 285, NVIDIA GeForce RTX 5090, 2 terabytes PCIe Gen 4, M.2, 128 gigabytes of memory in 4 DIMMs. They went for 32 by 4. Ooh. Bold move, Cotton. Let's see if that works out for him. It comes with a packing foam, which is important because the box was kind of trashed when it got here. The whole bottom and sides were retaped. Somebody saw it contained a 5090 and had their way with it. Oh, that's really awesome. It's a modular power supply, but it comes with the extra cables. Save these. Don't throw these out if you need this. Also save the handy reusable PC tote. So to take the foam out, all you gotta do is pop the side. And very gently do that. Internally, the configuration that we're dealing with from MSI is 3 front 120 millimeter fans and 1 rear 120 millimeter fan, 4 fans total. The power supply in the bottom, 1300 watts. MSI is not taking any chances. The most modest thing in here is our Tower CPU cooler, which for our 285 is going to be more than sufficient because we're not overclocking, we're not really doing anything exotic. Our M.2, our 2 terabyte, surprisingly, it doesn't have any extra cooling, but there is a fair bit of airflow. We'll have to see how this thing holds up when we get to the actual testing. There's a lot of interesting stuff here. Our 5090, it's the MSI 5090, the MSI version. It's got flow-through cooling, so it's going to dump a lot of heat in front of the processor, but you've got plenty of airflow from the front. We'll see how that works out in temperatures and everything else. It's also mechanically fastened at the front as well as the rear. So they've used all the screws to hold the GPU as well as the mechanical retention bracket at the front. This GPU is not going anywhere. It uses the 600 watt 12V2, like the modern version of the 600 watt power delivery. It is shoved in all the way. And in the rear motherboard tray, there is plenty of good cable management. So the cabling back here is not going to interfere with airflow or anything else. Interestingly, the rear side panel is a solid piece of metal, but this case design does actually also support mounting some more fans to do another intake on the side, but not with the side panel that the case comes with. I mean, you could maybe get a little bit of airflow there because there is a small gap, but I wouldn't really recommend it. This, because it is a business class machine, there's no RGB. It has an optical drive. Yes, optics, CD-ROMs. This is actually a thing that matters sometimes. So at the rear I/O, we've got a single Thunderbolt port, 4 USB Type 2 ports, 2 5 gigabit, 2 10 gigabit, our standard issue reverse SMA, Wi-Fi antenna connectors, and then 3 analog audio connections. It is nice to see everything in this entire case is completely standard. If you needed to swap the motherboard or swap the power supply or change something, you could. That's totally doable. It's totally standard. You've got 2 empty expansion slots. Those are 4-lane, and you've got 2 usable M.2 that are also accessible. There's no bundled M.2 heat sinks, however, in the accessory box or in the extra stuff that they gave you. So make sure that if you get an upgrade M.2 and it needs cooling, that you get one that comes with a heat sink or you get an aftermarket heat sink. For the front, for the dust filter, you just squeeze at the bottom and pull. But you got to be careful because if you do have the optical drive, you're going to have to remove the optical drive front before you do that. Otherwise, you'll just rip it right off. Now, my box is a little messed up in shipping, so the CD-ROM front was floating around the inside of the box or the inside of the carry bag. So your mileage may vary, but be careful when you take the front off if you have an optical drive because it can, be hard on the latches for the plastic front of your optical drive. So just be careful with that. But it's removable for dust filtering. The top does not have a fan. It is a mesh front, but there's no intake or exhaust fans at the top. You could add that if you really wanted to, but I don't think it's necessary. I think this is fine out of the box, but we'll see. Let's get to the benchmarking and the testing and see how this thing holds up. There you go. Now to do the testing, I got to leave the side on. It is going to be side on testing. Classic Microsoft start menu dysfunction. I start typing add, and it auto-completes add or remove programs because it knows that that's what I want. But the best match is apparently a web search on Bing, because obviously. Why do we want to go add or remove programs? Well, I'm sort of curious what the build out is on this. Like, how clean is the installation? It's got Norton 360. I got a free trial of Norton 360. That's going to be uninstalled. But what else is on here? Surprisingly, the machine is mostly pretty clean, except for that Norton 360 installer. And I've already started installing a bunch of our benchmarking stuff and all that kind of thing. But still, it's funny that add or remove programs takes you to Bing. Genius. Whoever thought about co-opting the start menu to drive the marketing dashboard up. I'm really surprised shareholders aren't suing the crap out of Microsoft for misleading analytics. But hey, whatever. So what's it been like using this thing for a couple of weeks? First thing, it's quiet. I never noticed the sound from this thing even when it was under full load. Second, I sort of gave it a worst case scenario in terms of thermals. Internally, the internal temperature worst case scenario was about 70 degrees C, with the hottest hotspot on the Ventus style 5090 GPU running at about 77, 78. And that was also really impressive because it pulled a maximum of 675 watts according to Hardware Info 64. If you're not familiar with, like, typically when you get a pre-built system, the parts are not overclocked. And if anything, they're underclocked, or they're not designed to run the full Monty. So the 12V2 power connector on the side here is clearly labeled 600 watts, which is great. That's something I look for. Not every power supply labels that. Not every builder labels that, even though they can deliver 600 watts. But it's always nice to have the positive confirmation that the 12V2 connector is 600 watts. And that's what I saw when I pulled the side off. But more importantly, the 5090s, especially some of the OEM versions of the 5090s from larger, that 5090 is never going to get 600 watts. It's going to be like 525 watts. This is running at 600 plus, and it can sustain. So that's very nice to see for those long-running, sustained AI workloads, or even game development, which we'll talk about in a second with Unreal Engine. There's some fun adventures there. So that is all great. 4 DIMMs, as expected, not amazing. 128 gigs. It would have been better to have 2 64 gig DIMMs. 428 gig DIMMs will get it done, but it does come at a little bit of a speed penalty, which we'll talk about in just a second. But otherwise, this is a perfectly reasonable system that doesn't have anything proprietary. It's an ATX case, an ATX motherboard. It has reasonable cooling. It has a reasonable setup for the GPU. It has reasonable thermals. And if anything, an overkill power supply. One thing that I would have liked to have seen is the M.2 heatsink. That does turn out to be an issue in artificial workloads. Now, if I'm running a 70-30 workload, 70% read, 30% write, that SSD is never going to throttle. I was never able to get it to throttle. But when I was pulling things from the network using a 25 gigabit network card, I added a 25 gig network card because I'm impatient. That's 2.5 gigabytes per second for just one channel, and copying 100 gigabyte AI models. When this thing had soaked for about 20 or 30 minutes of continuous copying, taking up, upwards of 500 gigabytes on disk, I did start to see some write throttling. Now, our temperatures as reported by Hardware Info 64 doesn't actually tell me if it was throttling, or if I was hitting like the media limit, like there's the caching mechanism, so it could have been the storage drive. But the reported temperature in Hardware Info 64 was like 82, 83 C, which according to the specs for the M.2 is the thermal, like the upper thermal limit. So it was staying under its upper thermal limit just barely. And so that's why I think it was throttling a little bit. Now, I didn't throttle down to 100 megabytes per second. It was still running at about 500 megabytes per second, but I wasn't enjoying the 2 gigabytes per second write speed that I was on the initial copy. So it's not bad, but it would have been nice to have a heatsink for that. In terms of expansion, having 2 more M.2 for those big AI models gives you plenty of room to add another 4 terabyte M.2. And I would recommend that you add an M.2 that has a heatsink, unless you have to run another giant card that is going to take up a lot of room, and then you might not have clearance for a giant, other card and some other connection. Could you run 2 GPUs in this system? You could, but I wouldn't recommend it. Does anything in here make sense other than the 5090? Like, could you put an RTX Pro 6000 in here with its 96 gigs of VRAM? You absolutely could. I don't think you really need to, though. For most of the kind of AI experimentation that you would do and creative workloads, the 5090 is the deal. I mean, this system costs less than 59, just a good 5090 when the 5090s launched, or about as much as the 5090s, because the price sort of hockey sticked. Well, fortunately, all the pricing for that is coming back down in line, and the pricing for these has fluctuated, so it's been hard to really nail it. It's like, oh, at that price, it's a really good deal. It's like, oh, at that price, it's a less good deal. So think about the time savings and the warranty aspect and all that sort of thing to know if this is a really good deal. But you can also put together, mid to high end parts in the same configuration and see if you get a really good deal. Now, I've got another video that I'm working on, or that just came out, where I picked up some Core i7, some Core Ultra 7, the 265K, I think that's the Core Ultra 7. They were on sale for $230 each, which I thought was an amazing deal. And that's part of what's going on here. This is a Core Ultra 9, but Intel's getting a little aggressive with their pricing. And for machine learning and getting work done at the right price point, that is a good setup. That is a good platform. And certainly the Z890 chipset and the higher end chipsets from Intel, those are really nice chipsets for features and peripherals and connectivity and that sort of thing. So yay, more compute per dollar. So let's get into the benchmarks. To set you up with the benchmarks here, there's the out-of-the-box configuration. Out of the box, there was no XMP profile set, and the power profile was Intel stock defaults. One of the things I like to do is compare Core Ultra 9 to Core Ultra 9. Now, this is the 285. This is not the K. This is not an overclocking K, but I still have the Intel Core Ultra 9 285. This is also not a K. Is there a performance delta between the two? Single core, no, there was no difference. This is something that's built. This is something that's pre-built. Should there be a performance difference? The difference is not the hardware, and it's not the configuration, and it's not MSI doing something weird. It is totally the settings in the BIOS. In this configuration, the BIOS defaulted to performance that gives the CPU an extra 100 watts. Even though it's not a K CPU, the CPU performance is plus 100 watts. It also has two DIMMs, two 64 gig DIMMs, and is otherwise running at the same memory timings, memory clock speed, mega transfers, same mega transfers, but only two DIMMs, so a little bit better timings. Also, XMP on out of the box versus not on for the first set of benchmarks. So for gaming, doesn't make a difference. Not really, a little bit maybe. Multi-core workload is really the only place where that makes a difference, and multi-core workload running on CPU. For our other stuff that we get into, like Unreal or creative workloads, it doesn't really make a huge difference. Maybe at render time for the creative workloads, but using the machine, not so much. Now, the second option is the performance, the Intel default performance. That is running our 285 at the lower 125-ish watt power target. It's the very conservative Intel setting. That power target is designed for a cooler like this. This is nothing. MSI has put a much better cooler in this system. So when we're talking about power targets, we could just set a higher power target. But you do get a warning that says this may introduce system instability. Don't think you're going to get warranty service if you turn that on and the system is unstable. But generally speaking, the system shouldn't be unstable if you turn that on. And it's not going to degrade your system. If you turn it on and it's unstable, and you turn it off and it's still unstable, you can get warranty service for that. That's not a problem. So we're going to rerun the benchmarks with the higher power target set and XMP profile 2. With that, in the benchmarks, we see that my DIY cobbled together 285 matches the pre-built 285, which is great. It's great to see. It's great to get confirmation that the parts here are not like the reject parts or the underclocked parts, in other words, which is awesome. Now, what about real-world workloads? Well, first, Unreal Engine. How does this perform as an Unreal Engine dev machine? I recently worked with Sentry to do take a look at their logging platform and do some stuff with that. And they have a GitHub project, a tower defense game on GitHub that is a game, but that also integrates their logging and telemetry stuff. And so Loaded that up on here, took that for a test, did some Unreal Engine dev. That worked out pretty well. Creative workloads with the Adobe suite, Puget Bench. Yes, the 5090 is pretty much the best bang for the buck for any creative workload. The only reason that you would need something beyond a 5090 is if you're working with like 12K textures that won't fit in VRAM. But you really, really, really have to have a particular workflow to push beyond 32 gigs of VRAM. There's a lot of stuff that has been optimized for 24 gigs of VRAM from like the last 3 generations of NVIDIA cards at the highest end. And a lot of folks in the creative industry, you know, that had 48 gig GPUs previously, a lot of that application tried to give you a little bit of breathing room at 48 gig. So for creative workflows, you know, we have the 5090 now that has 32 gig, and 32 is close enough to 48 that even when you start to overrun the 32 gigs of VRAM, it doesn't really start to negatively impact you, because the difference between 32 gigs of VRAM on this generation's not Pro cards and 48 gigs of VRAM on last generation's Pro cards, which is what everything was tries to size into. The penalty there doesn't hurt you too much. Sometimes in benchmarks you'll see, oh, the 48 gig GPU from last year is about the same speed as the 32 gig GPU from this year, even though the 32 gig GPU from this year has vastly more compute. And sometimes that is just because you're very slightly overrunning that 32 gigs of VRAM into system memory, which is slower, versus the 48 gig of yesteryear. And so in NVIDIA, I think that's part of the reason why we see 96 gig RTX Pro 6000s is they want the creative software to really ease into that lots of VRAM so that people are more willing to buy the more expensive GPUs, but also AI demands it. So there you go. That's the triple threat. This is for, you know, the game development stuff is great, creative workload stuff is great, and AI stuff is great. It is literally the best bang for the buck. If you're looking at like the NVIDIA Spark for inferencing performance, this will do better. And it's like, oh, it only has 32 gigs of VRAM. You're not going to be able to do stuff in 32 gigs of VRAM. Yes, but if you look at certain, like llama.cpp can run some of the layers on the GPU and some of the layers on the CPU. That's a whole thing. In fact, we did a video, it's kind of popular, about running DeepSeek R1 520 billion parameters in just 128 gigs of memory and 24 gigs of VRAM. Guess what? This will run that 520 billion parameter model. You want to run mixture of experts? You want to run IBM Granite? It's like, oh, I don't want to run DeepSeek. Okay, cool, no problem. Run IBM's Granite model, mixture of experts, GPT OSS 120 billion, plus some other parameters, and mix GPU and CPU workloads. You can do that on this system for dev. That's probably a whole other dimension of content, really. So overall, bottom line, MSI's build here is not disappointing, only because it is more or less what I would build for a no frills, no RGB, but high-end AI dev workstation. They haven't really made any mistakes. The cooling is adequate in the context of like what you and I would build, but in the context of like, oh, it's a pre-built OEM system, it is definitely head and shoulders above like what I see from larger big box OEMs like Dell and HP typically. The other big draw here is no proprietary parts. If the motherboard dies, you can replace the motherboard. If you wanted to replace the motherboard with not an MSI motherboard because, you know, you're upset, you can do that. That will work fine in this config. You can't really do that with other big box integrators or retailers. Oh, the GPU dies and you want to replace the GPU? Okay, well, the GPU is probably fine. That's not, you know, standard parts. Your shipper has damaged the front optical drive and you need to replace it with a different one. You can do that. That's fine because, again, it's standard. So this is a really sort of fun system to play with for the last couple of weeks, and I'm really glad that it has held up well. I'm pretty impressed with the build quality overall, given the pricing. I mean, obviously, do the pricing where you are. Take the parts, and know that the parts in here are reasonably standard. They're like middle of the road to upper middle of the road, Ventus style 5090. That's really the cost dominator in this thing. And know that the Core Ultra 9 processors, you can sometimes find a really good deal on those, and it's got pretty good tower cooler, et cetera, and do the math, put it together. Decide for yourself if is a value versus DIY. But sometimes you just want to buy a system with no RGB, get it done, and have one stop for your warranty. And in that context, this makes sense. I'm Wendell, Level 1. This has been a quick look at the MSI DP400 with the 5090. If you have any questions or I missed anything, or you want me to try another workload, let me know. Oh, I did try Linux. Linux on this works great. Even, you know, NVIDIA, everything, because it's all standard parts. Like there's nothing in here to not work in Linux. So if you want to run Linux, relatively modern distro, you know, like Omarchy or Arch or CachyOS or Bazite or any of that, it's gonna work great.